What happens is initially students join us in any of these disciplines. They get training, fundamental training on the practical aspects, what they learn in theory, right? After they get that training, they start coming to us for more independent projects. They do work on their own. They come up with their own ideas. Sometimes we give them ideas. We engage them pretty intensely, right? So teach them various techniques. That's not just limited to their coursework. They get exposure in this undergraduate lab how to think about research in the future. This is not just for an academic setting. Like, see, many of our students, of course, they are very interested in going for higher studies like graduate school and maybe PhDs and all this, right? For master's programs and PhDs. That's fine. We give them that training, they get comprehensively here. But then beyond that, there are career paths that they can take even to the industry. Typically, what you would have to do is do a undergraduate program, then do a master's, and maybe if you're lucky, you get some internship or something in an organic industry, like in a pharmaceutical industry, and then you go into that particular industry based on if there are vacancies here, right? Here, what we do is it's a BSc honors program, especially the chemistry program. They get full hands-on training on organic chemistry techniques, for instance, right? And they can use those techniques like right out of their graduating from Krea. They can go and join an industry and utilize those skills directly. Like, we teach them everything that's relevant to the modern industrial requirements. Then there's another thing I would like to speak a lot about. It's the Capstone projects. Again, this is something that is not common in undergraduate programs across the country. And these are not just ordinary capstone programs. These are not research. These are like a pre-PhD kind of training. Okay, they do independent projects. They do literature survey. They know how to go and read the literature, how to pass the literature, and how to get the relevant information and what it requires to make a good research question. So that's something that we train them intensely, because we are all the faculty here in all our departments, in the life sciences, the physical sciences departments, are researchers ourselves, So we try to make sure that these students get that same training that was imparted to us over a long period of time, all through our masters and then our PhD. So here students get that in an accelerated fashion. And they come and see this through experiments. We order chemicals for them, we have instruments for them, we have advanced instrumentation for them, which you would typically only see in a PhD level institute.
So Krea also offers many electives which are challenging. I think typically they are offered in the graduate level, but here they are offered to us so that we can experience it much earlier. And I think that will give us an upper hand going into our further career. Some of those courses include electrochemistry, group theory, advanced group theory, and NMR spectroscopy courses. Usually, even our professors said they're only offered in the master's or the PhD level, but here we are offered that, and it helps us challenge ourselves so that we can have an upper hand over other people when we go into our graduate programs.
Like I've said, our lab is not only used by chemistry students. We have physics students coming in. There are students who want to come and use nanoparticles, making nanoparticles and observing their light-based properties. Like you have plasmonics, like you have for semiconductors, or you have crystal displays, right? So all that you need some nanochemistry. So physics people come, they make the material here. We have all the chemicals, all the resources to make the materials, and then we have an advanced instrumentation lab, and we have other research facility. They can characterize those samples that they made. Have they really made it? What are its properties? These are the same tests, same techniques that are used in the industry also. So students from biology also come here, they make their samples here. We help them try to see the conditions that is best for their live specimens, for the biological specimens. And they come and use our labs, and even a lot of testing, a lot of ecology work that gets done here. So we have all the equipment, the basic tests that in this undergraduate lab, you have all the resources to do the basic kind of testing before you go into more advanced characterization. Once you have proof of what you've made and you know that you are going in the right direction, we have other labs which are part of our Krea facilities that they can do to finally make very concrete conclusions.
In industries, thiosulfate is used to find out to estimate the concentration of iron in some samples. To find out how much thiosulfate is present, first we have to do an iodometric titration, where we are using dichromate to estimate how much thiosulfate is there. but directly we can't do that. So we are using an indirect method of having potassium iodide to find out how much thiosulfate is present. So first we have to pipette out 20 ml of dichromate solution. We are using a pipette here because it can accurately measure 20 ml with the use of air pressure. So yeah, we have measured out 20 ml. Next, we are adding the potassium iodide to this 20 ml of dichromate. And we have to dissolve potassium iodide in dichromate completely. So we shake for a little bit. Yeah, once it has dissolved, we can see there's not much change in color. But the moment we add the hydrochloric acid, we can see that the color changes to dark brown. Now we have to keep it in the dark for some time. In the dark room, the reaction is equilibrating and we are making sure the reaction proceeds completely. After some time, it is ready for titration. Now we start titrating against the thiosulfate. We won't see much of a color change until it reaches about 18 ml of thiosulfate added. Then we have to add starch to the flask. Now we are adding a few drops of starch to the flask. It will turn intense blue in color. So as you can see, this is the end point. We can calculate how much volume of thiosulfate was used, and then we can do a back calculation, and using the amount of iodide we took, we can calculate the concentration of thiosulfate in the solution.